Hello and welcome to yet another video on my channel here. This is a Cauchy linear differential equation. It is a non-homogeneous linear differential equation with variable coefficients. As you can see, the coefficient of d square y by dx squared is x squared and the coefficient of dy by dx is x, right? Okay, now the power of x in this coefficient of d square y by dx squared is 2. So it's a second degree term which is the coefficient of d square y by dx square, and we have got a first degree term which is the coefficient of dy by dx. All right, now in order to solve this problem, we make a few substitutions. Okay, so what are the substitutions here? First of all, we substitute x by e raised to the power t. So it's an exponential substitution that we are making here. And this would imply that whenever we find log x, we shall replace it by t. Okay, this is one substitution. The next substitution is whenever we find x times dy by dx, we substitute that by dy, right? So this capital D here is the differential operator d by dt. Now the independent variable has been converted to t, and whenever we find x square by d square y by dx square, we substitute that by d times d minus 1 of y, or it is same as d square minus d times y. So this with these substitutions, we will get a new equation which we can write it down as follows. We can write that down as d square minus d times y minus, well, dy plus y is equal to t, correct? Because the right hand side is log x, which is equal to t. Cool. Now we have got a differential equation. Let's simplify the terms here, rearrange the terms here. So we get d square minus d plus 1 of y is equal to t, and we can write this down as d square minus twice d plus 1 of y is equal to t. So here the independent variable is equal to t and the dependent variable is equal to y, correct? Okay, so this is a linear differential equation with constant coefficients. So it is a non-homogeneous equation, of course. So we should, like, in order to find out the solution of this, we shall first find out what is the complementary function of this CF, and also we will find out what is the particular integral of this particular equation, which is pi. Okay, now in order to find out the CF, we need to write down the auxiliary equation. The auxiliary equation is as follows. So this can be written as d minus 1 times d minus 1 is equal to 0. So from here we can write down the roots of our equation, auxiliary equation, as m1 is equal to 1 and m2 is equal to 1. Now the roots, they are equal and real, right? So they are equal and real. So since the roots are equal and real, we write down the YCF, or the complementary function, as equal to C1 plus C2 times t. T is the independent variable, e to the power t, right? E to the power m1 t, or e to the power t. M1 is equal to 1, so it becomes e power t. So this is our complementary function. Let's save it as equation 1, and for finding out the pi, we look at we look at it as follows. So we shall write pi y of pi as equal to t divided by d square minus d square minus 2d plus 1. So this particular integral can be found out by using a division method. So what we do is that we divide t by this entire of the denominator, but in order to write down the denominator, we shall write down the denominator in its reverse order, right? So the constant term comes first, then the first order term, then the second order term. Okay, now in order to get this differentiation done, you see, if we multiply this the divisor by t, we shall get the term t here. But then we also will have minus 2 times d of t. So let's write it down: minus 2 times d of t plus d squared of t, and that and then like we'll have to subtract them and write down the remainder over here. So you see that d times t, right? So this is going to be equal to 0. Sorry, my bad. So this is going to be equal to 1, right? D of t is 1 and d squared t is going to be equal to 0, correct? So what we get here is basically 2, right, instead of 2 dt, and instead of d squared t we'll get a 0 over here. So what we do is we write down 0 here because t minus t is 0, and here we write plus 2. Okay, now we are done with the first step of division. The second step, for the second step, you see that 1 multiplied by 2 is 2. So we write t plus 2 over here. 2 multiply 1 is 2. 2 multiply minus 2d is, sorry, minus 2d of 2 is 2d of 2 plus d square of 2, right? Okay, now again, we'll follow the same rule over here, and you can see that d2 is equal to 0 because 2 is a constant, right? So this entire thing, 2d2 is going to be equal to 0, and d squared 2 is also equal to 0. So this d squared 2 is 0 over here. Now subtracting these two, we'll get 0 over here. So ypi is equal to t plus 2, right? Okay, now let's label this as our second expression, and therefore our general solution here is ycf plus ypi. That will give us c1 plus c2t multiplied by e power t plus t plus 2. But then if we scroll back a little bit up here, we see that e power t is essentially x and t is basically log of x, right? So we substitute those values here, and that will give us y as equal to, therefore this is our solution, right? Y is equal to c1 plus c2. T is logarithm of x, right? This entire thing is multiplied by x plus logarithm of x plus 2. So this, my friends, is our final answer to this question. Thanks for watching the video. Follow me for more such videos. Thank you. Bye bye.